Hello friends, welcome to my YouTube channel. Today we are going to discuss about steady state error. So it is the difference between actual output and the desired output. So this is the diagrammatical representation of the steady state error. The steady state error is the value of error signal, that is E of t, when this t is tending to infinity. The steady state error is the measure of the system accuracy. So this error arises when the nature of the inputs or the types of the system and from the non-linearity of the system components. So the error signal E of s can be given as R of s minus C of s into H of s. That is error signal we have here. E of s equals to R of s minus C of s into H of s, and the output signal C of s can be given as E of s into G of s. This thing we get here in the output side. The same thing, the output of the signal C of s equals to E of s into G of s. Now let us assume this as equation 1, this as equation 2. From the equation 2, this equation you have to substitute here in the equation 1. Now you get E of s equals to R of s minus E of s into G of s into H of s. So take this R of s outside because it's the input. I'm taking this to the left side, then you get this thing. Take E of s common and you just keep it here, then you'll get the E of s. This is the steady state error. Now if we apply the inverse Laplace transform to this equation, when you apply inverse Laplace transform, that means the S domain will change into T domain. E of s will change into E of t, and this is what happened. Now the steady state error is the value of the E of t when t tends to infinity, that I have already told you. So ESS, steady state error, equals to limit t times to infinity E of t. This is when you consider the initial value theorem, from initial value theorem. If we write in final value theorem, then s times to 0 we get. When we are writing in t times to infinity, then it is the initial value theorem. Okay, then this is what you get at the end of, means I'm substituting in the final value theorem, that is limit s tends to 0 s into E of s. S E of s, we already have the equation of steady state error, I'm just substituting it. So this is the steady state error, and we have error constants. When the control system is excited with standard input signal, the steady state error would be 0, constant and infinity. So the value of the steady state error depends on type, number and the input signal. So first one we have positional error constant, that is Kp equals to limit s times to 0 G of s into H of s. That is I'm telling in terms of final value theorem. Okay. Then the second one is velocity error constants, Kv equals to limit s times to 0 s into G of s into H of s. Just I'm adding s here, then it will become the velocity error constant. And another one is acceleration error constant, that is Ka equals to limit s times to 0. I'm adding another s to this, then it will become the acceleration error constant. Thank you.